Hello friends, I'm Professor Swanan Dongre and today we are going to see a new topic of basic electronics engineering and the topic is modulation and its need. Before starting this lecture, let us see what are the learning outcomes of this lecture. At the end of this lecture, students will be able to first explain the limitations of baseband communication and second elaborate the concept of modulation with its advantages. Before starting the modulation, let us see the baseband signal and baseband communication. So first, baseband signal. What is baseband signal? The electrical equivalent of original information signal is called baseband signal. The original information signal can be voice, it can be picture, it can be data, it can be music. When this is converted into its electrical form, that signal is called baseband signal. So baseband signal, it is present at the output of input transducer of any communication system, like microphone. When someone is speaking in microphone, his voice will be converted into its electrical equivalent form, and that is called baseband signal. The baseband signal is low frequency signal. For example, if you consider human voice, the range of human voice frequency is 300 Hz to nearly 3000 Hz. So its electrical equivalent baseband signal will have near about same frequency range. Now baseband communication. In baseband communication, the baseband signal is directly kept on communication media for transmission. For example, the data transfer between two computers or voice over local telephony. In these two examples, or for such examples, the electrical equivalent of original information signal, that is baseband signal, is directly kept on the transmission media for the communication, and this is called baseband communication. But the drawback of baseband communication is that the range of communication is limited. The signal can be transmitted up to certain limit only. That is, range of communication is limited. To overcome this drawback, we are using the modulation process. So the modulation process is used to overcome this drawback of limited range of baseband communication. Now let us see the modulation. For example, if you want to travel from one place to another place and these two places are far away from each other, then if you go by walk, you cannot travel that distance. So that is why what you are doing, you are preferring, you are using a bicycle or you are using a car, right? So in this example, you are a baseband signal which cannot travel over a long distance. So that is why what you are doing, you are taking the help of the another tool, and that is nothing but carrier. In this case, that carrier is nothing but your car. So this car will carry you over a long distance, and that is the concept used in modulation. In modulation process, you are having the original signal, that is baseband signal. It is also known as modulating signal. It is low frequency signal. And there is one additional signal, that is called carrier signal. It is high frequency signal. So in this modulation process, along with the baseband signal, which is low frequency signal, and it is called a modulating signal, there is additional signal is used, that is called carrier signal, and these two signals are given to the block, that is called modulator. This modulator will do the processing and it will generate the resulting signal, that is called modulated signal, and it is high frequency signal. Now what is happening in modulating process? In modulation process, any one characteristics like amplitude, frequency, phase, etc. of high frequency carrier signal is changed in accordance with the instantaneous amplitude of low frequency modulating signal. So what is modulation process? In modulation process, there will be change in one of the characteristics of this high frequency carrier signal. Which are those characteristics? These are amplitude, frequency or phase. And these characteristics are changed in accordance with the information signal, that is baseband signal, and if we talk more precisely, the instantaneous amplitude at that time instant, at any given time instant of that modulating signal or baseband signal, and it will generate the resulting signal, that is called modulated signal. So if there is change in the amplitude of this carrier signal, then it is called amplitude modulation. If there is change in the frequency of this carrier signal in accordance with the instantaneous amplitude of baseband signal or modulating signal, it is called frequency modulation. So this is the process in which your low frequency signal, that is baseband signal, is converted into high frequency domain. And we know that the energy of signal is directly proportional to its frequency. We know that E energy, it is equal to h nu, where h is Planck's constant. So that is why there is a direct relation between the nu frequency and the energy of signal. Once it is converted into high frequency domain, it can travel along long distance. Now at the receiver side, the exact opposite process is done. The modulated signal, when it reaches to the receiver, it will be separated from the carrier signal, right, and the baseband signal. The block there, it is called the demodulator, and the process is called demodulation. Now let us see the types of modulation, right. In this diagram there are different signals. First is modulating signal, second is carrier signal, third is amplitude modulated signals, next is frequency modulated signal, and last is phase modulated signal. Now if you see carefully, the first signal is modulating signal, that is low frequency signal. Its frequency is very low and it carries the information, right. The second signal is carrier signal. Carrier signal is the additional signal, and which is high frequency signal, right. Now what will happen in AM? In AM there will be change in the amplitude of this carrier signal in accordance with the instantaneous amplitude of this low frequency modulating signal. So that is why wherever the amplitude of modulating signal is low, the amplitude of AM signal is low. With increase in the amplitude of AM signal is increasing, again it is decreasing, increasing, decreasing. So that is why we are getting the envelope of AM. But if you carefully observe that in AM there is only change in the amplitude of this AM signal, there is no change in the frequency. Frequency of AM signal is same as that of the carrier signal. Now second, FM. If you carefully observe that in FM there is change in frequency. So wherever the amplitude of the modulating signal is maximum, the frequency of FM signal is maximum, and wherever the amplitude of the modulating signal is low, the frequency of FM signal is low. So based on the instantaneous amplitude of modulating signal, there is increase and decrease in the frequency of this carrier signal, and such resulting signal is called FM signal, right. So in FM signal there is change in frequency, there is no change in the amplitude of the carrier. The amplitude of FM signal is same as that of the amplitude of carrier signal. So there is frequency deviation, change in frequency in case of FM signal from its basic carrier signal frequency. So it can be greater than the carrier signal frequency or less than the carrier signal frequency. Then third signal is nothing but phase modulated signal. So here there is change in the phase of this carrier signal. Now this, as both these waveforms, modulating signal and carrier signal, these are continuous waveforms. So that is why there is continuous change in the phase of this phase modulated signal. In our syllabus we are having AM signal and FM signal. Now let us see next what is the need of modulation. So first, reduction in antenna height. We know that the antenna dimensions are always inversely proportional to the frequency of operation. The simplest antenna which we are using in any communication is the monopole, and whose height is lambda by 4. Now if you consider the monopole antenna height at 3 kHz, the height will be lambda by 4. Lambda is C divided by F. So that is why lambda by 4 will be C divided by 4F. C is the velocity of light or the electromagnetic wave in free space, and F is the frequency. So if you put it is 3 kHz frequency and the value of C, you will get the height of antenna at 3 kHz, it is 25 km, right. Now just imagine, is it possible to have the antenna whose height is 25 km? It is totally impossible. We cannot erect such uh, very high height antenna, right? So what we will do in modulation process, we are converting this low frequency signal into high frequency domain. For example, say this 3 kilohertz signal is converted into the high frequency domain with the help of say 300 megahertz carrier. So what will be the height of antenna? It will be lambda by 4 at that frequency, and at that frequency it is 0.25 meter, that is 25 centimeter, and you can easily fabricate this 25 centimeter antenna. It's highly possible, right? So that is why due to the modulation there is increase in the frequency of operation, and so that is why the antenna height is reduced. Then second, it avoids the mixing of signal. Now let us consider you are having three signals, signal 1, signal 2, signal 3. All these three signals, they are occupying the same frequency ranges, say 0 to 20 kilohertz, 0 hertz to 20 kilohertz, right? So these are, say signal 1 is the output of say first musical instrument tabla, second is of guitar, third is of say flute. Now if you transmit all these signals, signal of tabla, then the guitar and the flute, without doing any modulation, what will happen at the receiver end? These three signals will occupy same frequency range, that is 0 to 20 kilohertz. We cannot separate these signals from each other because they are occupying same frequency domain. So what we can do, we can use the three different carriers to modulate this tabla signal, then the guitar signal and flute signal. For example, the signal 1, which is tabla signal, it can be modulated with the help of carrier of say 300 kilohertz. Then the second guitar signal can be modulated with the help of the signal carrier signal of 200 kilohertz. Then the flute signal can be modulated with the carrier of 100 kilohertz. Now if you consider at the receiver end, these three signals, they are occupying different frequency ranges. One is centered at 300 kilohertz, second is centered at 200 kilohertz, and third is centered at 100 kilohertz. So that is why we can now easily separate these signals, and this is nothing but the modulation avoids the mixing of signal. Next is multiplexing is possible. What is multiplexer? Multiplexer is a device which has number of inputs and single output, and at a time only one input line will be connected to the output line, and the reverse of multiplexer is demultiplexer. It has single input line and multiple output lines. These multiplexers and demultiplexers are widely used in telephone networks. Now multiplexing means it is possible to carry the different signals, right, through a same communication media, right? Now if you consider there are three signals, signal 1, signal 2, signal 3, and this is the multiplexer, the single output is there. What will happen? We are using carrier F1 to modulate the signal 1, F2 for the modulation of signal 2, F3 for the modulation of signal 3. Now what will happen? At these three signals, they are occupying the different frequency ranges in the frequency domain. So that is why they can easily travel through this single communication medium without any mixing. So that is why the multiplexing is possible due to the modulation. With the help of modulation, we can modulate the different modulating signal with different carrier frequencies, and it will avoid the mixing of signal. Next is it allows long distance communication. We know that with increase in frequency, the energy of signal is also increased, right? E is equal to h nu. Nu is nothing but the frequency, and h is Planck constant. So that is why there is direct relation between the frequency and the energy. If the frequency of signal is increased, then its energy will also increase. And once there is, due to the modulation, low frequency signal is converted into high frequency domain. So that is why its frequency will increase and its energy will also increase. And due to the increase in energy, that signal can travel over a long distance. The next, the modulation improves the quality of communication. Due to the increase in the energy of signal and due to the change in the characteristics due to the modulation, the effect of noise is reduced. So that is why it improves the quality of communication. Now let us see some assignment questions. What is baseband communication? What are the limitations of baseband communication? What is modulation? Explain the need of modulation. So thank you friends. See you soon with new topic.